Hello, dear students. Welcome you all for Become a Good Problem Solver event organized by the GEM Foundation. In this video, we will see the solution for the math problem published on BGPS August 2025. The theme for that month was about applying fractions from a visual perspective for juniors and applying fractions and developing the analytical thinking skills for seniors. So, for both of these problems, we have published a set of guiding questions that can help you work on these problems and arrive at a solution. And in this part of the video, we will also discuss about the UPA technique, the research proven 4-step technique, which will help you work on problems. So the understand, plan, execute, and reflect part, which will help you systematic steps to approach a problem and work systematically. And in order to understand a problem, you would actually need some kind of a guidelines or a framework. So first you can underline the key terms and ask some guiding questions which will help you understand better what is the information asked, what you need to find, and how to kind of work on it, and then draw or model to understand the problem and link the concepts and look for any patterns or relationships. So we'll apply these understanding techniques here. Let's start with the junior problem where we'll read the problem first. Raju made a drawing and it had a square in the middle surrounded by small squares on all four sides without any overlaps or gaps, right? And then the middle square and all small squares form a big square. If the side length of small square is 1/3 of the side length of the middle square, can you find how many small squares are there in the drawing? If the side length of middle square is 6 centimeter, what is the total area of the square formed by the whole drawing? So this is the question that's been asked. Right? What is the total area and how many small squares that are in the drawing? So let's say what the guiding questions we have published are. Underline the key important words. Yes, so this is about a square in the middle, and the middle square and all small squares form a big square, and there are no overlaps or gaps. And then the side length of small square is 1/3 of the middle square. So basically, the second guiding question says, what does 1/3 mean? Yeah. So that's quite straightforward. 1/3 means, in one whole, it represents one part out of the three equal parts. But here in this case, what does 1/3 of the side length of middle square? So let's take a small example, because whenever you actually work on such problems, taking small examples will help you very well. So for example, if the middle square's length, side length, let's say it is 3 centimeters, then the small square's length, what it would be? Small square is nothing but 1/3 of the middle square's length, right? So 1/3 of 3. So how do you find 1/3 of 3? It's something but 1/3 into 3 is 1 centimeter. So if the middle square is 3 centimeters, small square's side length will be 1 centimeter. So that's what 1/3 would mean. And we have taken a simple example and understood how to draw. Maybe let's try drawing it first. So if I'm drawing a middle square of 3 centimeters side length, right, like this, and this is surrounded by a small square, each having 1 centimeter as the length. So let me draw the side square with the red color, and it says it does not overlap or having any gaps and form a bigger square. So maybe, which means I should just draw the smaller square like this next to each other, right? And maybe just draw all around the middle square like this. Yeah. But then remember another important word that has been mentioned here. The middle square and all the small squares form a big square. So currently, does it form a square shape or no? It forms some kind of a crisscross shape, right? So in order to form a big square, I maybe also need to draw another small square like this. So now I think we can see that this forms a very big square. Yes. Okay, and how many squares are there? How many small squares are there in the drawing? So I can easily count and tell. Okay, it's like 1, 2, 3, 4, 5. Another 1, 2, 3, 4, 5. 5 plus 5 is 10, and 1, 2, 3, 1, 2, 3. So 10 plus 6 is 16 small squares are there if I draw in this kind of a setup. Additionally, it also is asking if the side, so in this case, I have taken the side length of the middle square as 3 centimeters, right? But then in this question, it's been told that the side length of the middle square is not 3 centimeter, but it is 6 centimeter. So then now you have got an understanding. Okay, now let's plan. So what is the plan? Okay, I know how to draw and find the number of squares, but the question is, instead of having a 3 centimeter as the middle square length, I should have 6 centimeter as the middle square's length. So let me draw the middle square again, maybe here in the bottom. It's about 6 centimeter, right? So 1, 2, 3, 4, and then 5, 6. And then the same thing goes on all sides. Okay, 3, 4, 5, 6. And then again on the other side. And then on this side as well. So I have drawn 6. And then what will be the side length? I know how to find the side length of the small square. It is nothing but 1 by 3 of 6. And what is 1 by 3 of 6? It is 2 centimeter. So then I need to draw squares of 2 centimeter length, side length, right? Like this. So then how many squares I would need is the question. And like I already mentioned and drew here, should also include the last corner, only then it will form a square, right? Okay, so this is how it would be. So now I think you're all able to understand this design of having the squares inside squares and then forming a bigger square, right? And also following some fractional rule. So this is an interesting problem where you apply fraction for designs, and there are many interesting aspects in this, which you would be like, if you have an eye for understanding math concepts, you can find many such relation between the small ones which you drew first and then this one with 6 centimeter. Anyway, so now how many big squares are there? Will it change? Let's see. So in the case of our first one, we saw there were 16 small squares, right? So let's see what will be the case in the case of a bigger square. Can it be different or same? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, it's same. 16 small squares, right? Wow. And the question is also asking about what is the total area of the square formed. So how do I find the total area? I think you all might be knowing area of a square can be found by multiplying the side length of the square by itself, right? So side into side is the area of the square. So let's count how many sides. So do I just count like this as one? No, because this is 2 centimeter, right? That's what we figured out. So 2 centimeter. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. So the bigger square that is formed is 10 by 10 in this case. And therefore the area of the square is 100 square centimeter. Yeah. So when the middle square side length is 6 centimeter, you get an area of 100 centimeter. And actually in this case again you may get 3, 4, 5. So this is 5 times 5. So in our sample example, you get an area of 25 square centimeter. And for the actual question, the area of the entire square will be 100 square centimeter, and the total number of squares is the same, which is 16 small squares. So we did executed with the values, and as part of the reflection, where you are actually learning something different as well, you can see that when the ratio or when the small square and big square is followed with certain specific fraction, then you can see that the small squares formed outside will be the same. For example, you can actually think instead of 6 centimeter, you can draw a 9 centimeter in the middle square and see how many outer squares it will form. On that case, you can think that the outer square, the small squares will be 1/3 of 3 is 1/3 of this 9 is 3 centimeter. So each will be 3 centimeter. But then if you draw it actually, you can see that the outer small squares will still be 16 small squares only. Why? Because it is based on the fraction of 1/3 of the middle square. Yeah. So such interesting observations you can make, and also the patterns will also form with the area that is formed out of this kind of a rule. So this is the aim of this BGPS event, to kind of ignite your curiosity and nurture your thinking and apply fractions from a visual perspective. I hope you had a good learning experience. Please do try it out and then check how the guiding questions and the Uber technique are helping you to work on these problems and provide solutions. Please do keep in tune for the upcoming BGPS events and participate in large numbers. Thank you.